Hello everyone, my name is Zehra Gümüşok and I'm a first year industrial engineering student at Bilkent University. Today I will be representing my Physics 102 laboratory project. My project is titled as Investigation of Electromagnetic Induction, the Effects of Coil Returns and Area on Induced Electromotive Force. And the aim of this project is experimentally observe Faraday's law of electromagnetic induction by studying the effect of varying number of loops and coil and fields on the induced electromotive force. And the measured data will be compared with theoretical values in the law. Faraday's law states that a change in magnetic flux over time induces an electromotive force, and magnetic flux is calculated by the magnetic field and the multiplication of area. To do my experiment, I will need a multimeter, a magnet, a ruler, 3 coils with same radius and varying turns, and 3 coils with same turn and varying radii, and crocodile cables. At the first stage of my experiment, 4 copper coils will be prepared, and each with a varying number of turns, and the radius of the coil will be remaining the same throughout the experiment, and the magnet will be released from a specific height through each coil, generating the magnetic field to change. The multimeter will be used for recording the induced electromotive force, and the same procedure will be applied to each coil to examine the influence of number of turns in the magnitude of the induced electromotive force. And at the second stage, 4 coils with a constant number of turns but varying radii will be used. The same bar magnet will be dropped from the same height through each coil to induce an electromotive force, which will then be measured. By analyzing the electromotive values for different coil radii, the effect area of the coil on induced voltage will be determined. At the first stage of my experiment, I determined the radius as 2 centimeters and increased the number of turns, respectively, as 20, 30, and 100. A coil with 2 centimeter radius and 20 number of turns was measured as 1.8 voltage, and second coil with radius 2 centimeter and 30 times number of turns was measured as 2.5. And the third coil with radius as 2 and number of turns as 100 was measured as 9.7. In the second part of my experiment, I determined the radius of the coil as 2 centimeters and number of turns as 10, and then I measured the voltage as 1.5. And for the second coil, I determined the radius as 4 centimeters, number of turns as 10, and I measured the voltage as 4.5. And for the third coil, I measured the radius as 6 and number of turns as 10, and measured the voltage as 8.9. To compare my measured values with theoretical data, I made an error analysis for different number of turns and different number of radius. There might be errors caused by instruments accuracy since the equipments will be used to have limited precision, and the ruler used for measuring the radius of the coils has limited precision. Magnet releasing height inconsistency and releasing angle may cause an error in each repetition. Potential differences in the coil construction and external electromagnetic interference will be ignored in both stages, and I will be calculating the percentage error. So this experiment highlighted the importance of careful coil design and consistent experimental conditions in studies of electromagnetic induction. It also reinforced the principle that induced electromagnetic force is directly proportional to both the number of turns and the area enclosed by the coil, providing strong empirical support for Faraday's law. And in this experiment, Faraday's law of electromagnetic induction was successfully demonstrated by analyzing the effects of varying the number of coil turns and coil radius on the induced electromotive force. The results showed a clear direct relationship between the number of turns and the magnitude of the induced voltage. As the number of turns increased, the induced electromotive force also increased. Similarly, increasing the coil's radius and therefore its area resulted in a higher induced voltage, confirming that the larger area allows for greater magnetic flux changes.